This is the video representing Group 16. We are all four of us online students. We call our project Project SCADA. It is a play on an acronym that is well known in the industry. For us, it means Smart Current Analysis and Data Acquisition. The SCADA project is meant to make energy monitoring cheaper in terms of hardware required. Our intent is to monitor current at a home's main source of electricity, preferably between the meter and the breaker box. Our plan is to record this current and analyze it so that the end user has an idea of what appliances are using the most power. One of the ways we want to accomplish this is to run an FFT on a current sample. Once the FFT is complete, we intend on being able to identify frequencies with higher amplitudes when certain major appliances are on. We are not quite sure how we want to accomplish this yet. At this point, we're still researching and experimenting with different microprocessors to decide what will work best. Right now, the ARM Cortex-3 of the Arduino Do is something we're investing ourselves in. We feel like the processing power and the analog to digital converter speed will be useful in gathering data to analyze, and that the Arduino is fairly well supported online. We also want to analyze the current in terms of time. By this, we would monitor the startup current signature of each major appliance. We feel like loads such as water heaters will look different than loads such as a well or an air conditioner when they start up in terms of current amplitude. Pretty well the same as the FFT, but another way of monitoring and confirming what we've got with the FFT. The next thing I want to do is we want to introduce ourselves and what we can bring to the group and to the project. My name is Brandon Ward. I have 13 years of experience in industrial electronics, mostly in the power industry. I have a lot of experience with motor current signature analysis, which I feel like will be useful, and that I will be able to provide useful input for the project, and in that sense. I feel like the project is going really well. All of us, I think, have an interest in, and I think we all chose to be a part of this project because of what we think we can get out of it, and I think we all want to see it succeed. So I feel like regardless, it's going to go well, and we're probably going to have a good project in the end. With that, I'm going to turn it over to the next teammate, and he can explain his part.
Hey everyone, my name is Keith Snyder. I'm an online student from Memphis, Tennessee. I work in QA doing system testing for positive train control for a Class 1 railroad. So in addition to helping out with the system design, I hope to be able to use my experience in testing this device through a range of different scenarios to hopefully improve product performance. As Brandon said, we've decided to start a design based on the Arduino Do platform. So what I have here for you is a very simple proof of concept demonstration. So here's my setup. We're at my main breaker panel at the house, and I have a current transformer on each of the split phases coming into the house, and they're each going across a burden resistor there. So here's a scope showing the waveforms for each phase, and the output here is based on the program running on the Arduino. You can see downstairs AC is off, upstairs AC is off, and the microwave is off. It's showing the frequencies around the first three harmonics, 60, 120, and 180 hertz, and the number to the right of that is the change from the most recent FFT to the oldest one in the buffer. The idea being that we can look at that change and determine when an appliance is turned on. So what I'm going to do now is throw the breaker for the downstairs AC. Let's see the spike in the current there, and hopefully we do. The downstairs AC is on now. You can see based on a large change here around that first harmonic there. So I'm going to go inside now, and we'll look at the microwave and see if that works as well. All right, I'm here in the kitchen now. This computer is just mirroring the one that's in the garage connected to the Arduino. So we see we still have the downstairs AC running, and the microwave is off. I'll turn the microwave on. and we'll see the current waveform change. See, it's only going to be across one of the phases because it's 120 volt appliance. Now we see the microwave is showing on. Now it's off, and the program's showing it off. All right, thanks for watching. I'll pass it on now to Eric.
Hi, my name is Eric Bentley. I'm also an online student out of Connecticut. I work for a company that provides simulators for the maritime industry. Think flight simulators, but for ships. Specifically, I work on marine propulsion plant simulators where marine engineers train in the operation and management of engine rooms. My job has me doing a lot of hardware I/O troubleshooting and interfacing custom hardware to our simulators. This experience comes in pretty handy when working with the Arduino microcontroller, which is very similar to our proprietary microcontrollers. For the SCADA project, I'm taking on the task of the user interface. Locally at the Arduino, we plan to have an LCD screen like this one that prints out the raw data, so you can view that when you're at the device locally. Then through Wi-Fi, we'll make the Arduino a web server and output the data to a website so it can be viewed remotely, along with the ability to control certain functions from that website. As Brandon said earlier, we're all very excited about this project and look forward to producing a solid prototype. With that, I'll hand you over to Zach, who will discuss the project plan for the rest of the semester. Thank you.
Hi, I'm Zach McKinney. I'm out of Houston, Texas. 15 years of instrument and electrical work, starting with the nuclear Navy. I'm with a pipeline company, like I said, downtown Houston. Wonderful commute out in the middle of nowhere, Damon, Texas. For the month of October, we're really looking to have a good specification nailed down. We're doing a lot of learning with the technology and what it's capable of, and we're still coming up with great ideas. Generally speaking, we know what we want, we know what we've got. You've seen some great examples of code and the kind of interface we're going to put together. And so we're really looking to hammer everything out so that we can run this thing in November and start working on cleaning it up and deciding what our final product's going to be, so that we have a good pilot test by the end of the semester and a good plan for 2019 and EEE 489. Thank you for your time.